In this video, we're covering length, midpoint, and gradient. Now, there are several formulas we need to use, so we're going to be focused on each one of those individually. So the first one is what we call length. So the length of an interval, or just a line, so interval just means line, is the distance from two coordinates, and the formula we use is d equals, so we're looking at this here, the formula here is d equals the square root of x squared minus x1 all squared plus y2 minus y1 all squared. So, if we're given 2 points, so we're given A, which is at 5, 3, and B, which is at 7, 2, we need to use that formula to find the length. So I'm going to write those points down. The next thing I want to do is label what each of these points are in terms of my x1, x2, y2, y1. So A is my first coordinate, so I can say that 5 is x1 and 3 is y1. And then again with B, 7 will be x2 and 2 will be y2. Now that we've got those, all we need to do is substitute these values into our original equation. So if D equals the square root of x squared minus x1, it's always a good idea to write these down until you can memorize it in your head. Alright, so we got that, and all I'm doing is I'm going to replace my x2, x1, and y2, y1 with what we labeled them up above. So my x2 we said was 7, so we get 7 minus my x1, which we said was 5. Now we have y2, which is my 2, minus my y1 value, which is 3, and that's squared. So at this point you use a calculator, and that gets us a value of 2.236067977 ... We're just going to round it to 2 decimal places, so 2.24. Alright, so that the length of the line connecting those 2 points, connecting A and B, so if I had A over here and B over here, right, that length of that line there is going to be 2.24 units. Alright, so the next thing we want to look at is midpoint. So the midpoint of an interval, or that line, is the point halfway between the two coordinates. So it is a coordinate, so you get two values, you get your x and your y value, as you can see in the formula there. So we have a formula, we have x1 plus x2 over 2, and we have y1 plus y2 over 2. All this is the average, alright, of your 2 points. So again, it's always good practice to write down your coordinates again, and then label which one's which, so x1, y1, x2, y2. I know it's tedious, but it's good to remember to write these basics down so you don't make a simple mistake. We then write down our formula. And now we replace our x1, x2 with their values. So x1 was 5 plus my x2 value, which was 7 over 2. Then we get y1, which was 3 plus y2, 2 over 2. Now when you go to put this in the calculator, you do each one separately. So you would use this one first, then you'd go and do this one second. Don't try to do them at the same time. So our first coordinate is 6, and our second coordinate is 2.5. Alright, so we know the midpoint of the two dots. So if we have A here, and we have B over here, we have the line connecting it, our midpoint is here at 6, 2.5. Alright, the gradient. So the gradient of an interval measures how steep it is. So if the line's going from bottom left upwards, like this direction, that would say we have a positive gradient. It's going upwards. Now, if we have something the opposite, going from top left to bottom right, like that, where we're going downwards, we say that is a negative gradient and it has a negative value. Okay? So there is a formula, y2 minus y1 over x2 minus x1, and gradient is the letter we use for representing that is m. So here, as always, write down your values, your coordinates, label them. So by now you should know x1, y1, x2, y2. We want to write down our formula. So m equals y2 minus y1 over x2 minus x1. We substitute our values. So y2 was 2, take my y1, so 3 over 7, take away 5. And that comes out as -1/2, which means we're going in a downwards direction. So the line would be coming down the page like that. Alright? Alright, last thing we need to look at is something called the angle of inclination. So this is the angle that a line makes with the x-axis. So on the left there, you can see we have an acute angle that it makes here, and we know that's a positive gradient. Whereas if we have an obtuse angle, alright, which is greater than 90, we know we have a negative gradient. So there is a formula for this, and it's m equals tan theta. Alright, theta is that symbol there, and we use that to represent angles. So the first question is, find the angle of inclination of a line with gradient 3. So if I write down my formula, m equals tan theta, I know my m is 3 equals tan theta, and then we need to remove our tan, and we use what we call inverse tan, so -1, -1. So tan -1, 3 equals theta. And you would put that into your calculator. So to put that in the calculator, you go Shift tan, and then put your 3 and click Enter, and you'll get 71 degrees, roughly. Now, the opposite, we can find the gradient of a line with an angle of inclination 60. So again, m equals tan theta. So we're trying to find m this time, but I know tan is 60 degrees, so I can just put that in the calculator, tan 60, and you get 1.73. So that has a gradient of 1.73. So to end the video, we'll quickly do a recap of all the formulas we used. So given that you have two coordinates, you have x1, y1, and you have x2, y2, so a and b. The gradient is found using the top formula. The next formula is your angle of inclination. The second last one is your midpoint, and the last one is your distance formula.